So what exactly, before starting differentiation, one thing we must know is function. So any idea about what is a function in maths?
I know it's represented as f of something, or like generally f of x.
Okay, so that is how it is represented. Okay, so we'll see. This is actually a representation, or you can say relation between two variables. So for example, I can say y is equals to x plus 3. So in this, y and x are related, right? So for every value of x, you will get a value of y. And for every value of x, you will get only one value of y. You won't get two values of y. That is what a function is. So commonly it will be represented as y is equals to f of x, and that f of x can be anything. Here this f of x can represent many things. For example, it can represent, as we have seen above, x plus 3, or f of x can represent, say, x square, or f of x can represent sin x, a trigonometric function. So all these are different functions, right, represented by f of x. And f is not compulsory. It can be g, it's up to us. What we want to show here is that y depends on x, or y changes with x, right? So for example, if I say y is equals to x plus 3, so my f of x is x plus 3. Now for different values of x, you will have different values of y. For example, if x is 0, y will be 3. What will be value of y if x is 1?
4.
4, sir.
4. Okay. And what will be y if x is minus 3?
0, sir.
0. So these are different values of y for values of x. So we can see here that x is, whenever x changes, and when x is changing, y is also changing. So that was our first example. And same way, suppose second example was what? Y is equals to x square. So for values of x, you will get some values of y. So now, if y is 0, if x is 0, y is 0. If x is minus 1, y is 1. If x is plus 1, y is 1. If x is plus 2, y is plus 4. If it is minus 2, y is still plus 4. If it is minus 3, this is 9. If it is 3, still it is 9. So these are two different functions. And we can actually have, or we can, so that is representation of that function. And we can also represent this function on a graph. And the first part you must have already done earlier. That is representing a function like this. This function, such expressions you must have seen when in your previous classes you would have done linear equations, right? What does that mean? So I can plot these points here. Okay, what all are the points? Points are 0, 3. X is 0, y is 3. This is 0, 3. Then when x is 1, y is 4. So this is 1, 4. And when x is minus 3, y is 0. That means this is the point. That is -3, 0. Right? Now, what happens now is if I want to join these points, I can see that if I start from this, it is actually a straight line. So this is a straight line. And because the graph of this expression x plus 3, y is equals to x plus 3, if we plot it on a x-axis and y-axis, we see that that graph is actually a straight line. That's why we say that this is linear graph. And if it is part of an equation, we say that that is a linear equation. Right? So that was one such examples. Next, take this example, the second one. So here it says y equals to x square. And now if we start plotting the points, so when x is 0, y is also 0. When x is 1, y is 1. And when x is -1, then also y is 1. Then at 2, x reaches 4. And at -2 as well, it is 4. And then at 3 or -3, it actually goes to 9. So this is 4, 5, 6, 4, 5, 6, 7, 8, 9. Right? And at -3 also it will be 9. So these are the points. And now if I want to draw a straight line, we'll see that this is not a straight line. If I join any of the 2 points, I won't be able to join other points. Right? You can see it will leave the other 2 points. So this is not a straight line. Is it clear? So it is not a straight line. What actually it is, it will be a curve. So if I start joining them now, one by one, so I'll end up drawing a curve like this. Is it clear? So what do we get? We get a curve like this. The objective is to show you that if y changes with x, if one quantity changes with another quantity, the two quantities can be represented on a graph, in a two-dimensional graph, where we can easily visualize that change. Right? So now if you see, if you compare these two graphs, we can see here that in the first case, the linear graph, if there is change of 1, in y also there is change of only 1. I mean, if x changes by 1, y is also changing by 1. You check anywhere. You check these 2 points. This is -1, this is 0. So x has changed by 1 and y has changed from 2 to 3. So y has also changed by 1. Right? But you see here, x changed by 1 here from 0 to 1. But y has changed from 0 to 1. But when x changes from 1 to 2, change in x is still of only 2, but y changes by 3. Next, when x is increased by 1 more, that is, it goes to 3, then now y has reached 9. That means now it has increased by 5. So the delta or the change here is 5. That is plus 5. Change here is plus 3. And the change below that was plus 1. So we have seen that this is the screen visible, because just now the current, there's some problem. Is the screen still visible to you?
It zoomed out, sir. It's too big.
Okay, that is okay. Now it is okay, right?
Yes, sir.
Okay. So what we are seeing here is the when the two quantities are related, change in one may be reflected in the other. So y is here changing with x. And we have seen two types of changes. First change, where there is a linear graph, the change is consistent or the change is uniform. But in the second graph, you can see that the change is not uniform, right? So there are two types of changes here. Now, that was about functions and how functions can be represented in a graphical form. Next question or next thing which we need here, and such things are very useful in studying physics. For example, this x and y can represent two different things. For example, it may represent x may represent time, y may represent distance, right? This x-axis, it may represent time, and y-axis may represent distance. X may represent time, y may represent velocity or speed. X may represent time, y may represent force. So that way we can actually plot the change or the relation between two physical quantities as well. Okay, so let's start that. So here we have seen that change in x introduces a change in y. Here also change in x introduces a change in y. But in this case, we have seen that the change in y is consistent for consistent change in x. What does that mean? So that for that we can see this table as well as the graph. So here, what is the change in x? 1. And here, what is the change in x? 1. Here, what is the change in x? It from 1 it goes to -3. That means it is -4. And the same is the change here. Correct? And if I increase this graph, or if I keep on adding more values, I'll see the same pattern. For example, now if suppose instead of -3, if x is say 4, in that case what will be y? If x is 4, y will be 7, right? So now what is the change here? Change here is plus 7, and here also change is plus 7. What I am saying is change in y is consistent with change in x. I am not saying that change in y will be equals to change in x. Incidentally, here the change in x and y is same. Whatever be the change in x, that is the change in y here as well. But I have not written the same thing here. What I have written here is that change in y and change in x are consistent. For a consistent change in x, there will be a consistent change in y. That means, what does that mean? So we'll take another example. Say for example, y is equals to 2x plus 3, right? And if I plot this graph, this will also be a straight line. Now, suppose now try to plot few or try to uh, list down some points x and y values, different values for x and y. So if x is say minus 3, y will be minus 3 into 2 plus 3, that is
-6.
minus 3. If x is minus 2, then y is
-1.
suppose minus 1 plus 1. If it is 0, 3. If it is 1,
5.
5.
yeah. And if it is 2,
7.
7.
okay, last. If it is 3,
9.
And
9.
9.
right? Okay. So now what do we see here? Every step x is increased by plus 1. Right? And what is the increase in y? Is it plus 2? So these are the two graphs. So that's what I mean when I say consistent change in x will result in consistent change in y. So it is not equal change. It's not like if x is changed by 4, y will also change by 4. Right? So here, incidentally, we had the case where change in x was equals to change in y. But here what we have seen is equal change in x creates or produces equal change in y. That is, such changes are called uniform change. So things are changing uniformly. Y is changing uniformly with x. It's not like somewhere x is somewhere or at some point of time or at some instant y is or change in y is faster as compared to some other point. That's what we mean by consistent or uniform change. But if you see this case, the second case, it is not like that. Here, if x is changed by 1, change in y is 1 at this point. But at this point, change in y is from 1 to 2 also delta x, that is change in x is 1. But what is change in y? Change in y is 3. This is plus 3 change. From 2 to 3, x has changed by 1. But y has changed from 4 to 9. That means this is the change in from here to here, 4 to 9. That means it has changed by plus 5. Such changes are called non-uniform change. So these are the two basic things which we have seen here, that one change is consistent, another change is non-uniform change. So whenever one quantity varies with a change in another quantity, we can also think about whether that change is fast or slow, right? Or we can say that we should have a measurement of, or we should know how to measure the rate of change of one quantity with respect to other. right? Not only in physics, we need it in many cases. For example, population of a country may increase or decrease with time, right? And you may have to compare increase in population of one country with that of another country. So this rate of change of population is something which we need to study in that case, right? Same way, there can be, if you watch a cricket match, so in that you can say overwise, there will be scores will be given. And from that, you can find out what is the run rate. That is runs scored per over. And we need that to understand or to analyze which team is playing better, whose run rate is better, right? So this rate of change is not only with respect to time, it can be with respect to any other data as well. For example, as we have already seen, it can be rate of change of population, that is with respect to time. We can have rate of change of, or the rate of scoring of runs, that is with respect to overs, right? So now what we have to do is, now we have to have a technique of studying these rate of changes. When the change is uniform, right, here. So we represent, say, y as one quantity and x as another quantity. Now change in y will be represented as delta y, and change in x will be represented as delta x. So this is to represent change in y and change in x. So when we say rate of change of y with respect to x, that means we are talking about delta y, that is change in y with respect to, that means divide by change in x, that is delta x. This is rate of change with respect to rate of change of y with respect to x. Is it clear, this part, that this is nothing but rate of change of one quantity with respect to another quantity?
Sir, can you
N-
explain once more, please?
okay, what I said is, we denote or represent change in y as delta y. Basically, delta represents change. This is
Yes,
to
sir.
represent change. So change in y. So and we said that there is a rate of change. So rate of change means, as you can see here, there must be change. So rate of change
Yes,
of
sir.
one quantity with respect to rate of change of, I mean, with respect to another quantity, say x. So that we will represent as delta y by delta x. And we need this in many
Okay, sir.
places. For example, say one quantity x represents time and another quantity y represents distance. So now what does that mean? Delta x will represent what? Change in time. And what will delta y represent? Change in distance, right? So what will be rate of change of distance? Rate of change of distance with respect to time. I'll say that will be equals to delta y by delta x. Is it clear now? It is just to show the difference.
Okay, sir.
I mean, it is just to represent this rate of change of one quantity with respect to another quantity. And what exactly is this quantity called? Rate of change of distance with respect to time. Do we have a special meaning for this or special term for this? So this quantity is nothing but speed, right? So instead of y, if I am using distance, and x is time. So x, we have chosen x, right? You can choose t. Here you can choose anything else. For example, you can choose s. So now what is speed? Speed is delta s divided by delta t. Correct? Change in time divided change in distance divided by change in time. Okay, now coming to this, that is when we had this expression. So this also represents that y is changing with x, and we have drawn so many points, right? So suppose now I take 2 points out of this, say point -2 and point 1. So this point will be called x1, and this point, suppose we represent it by x2. So for that, or corresponding to that, this is point y1 and this is point y2, right? Now in the same example, in this example, if I ask you what is delta y for those two things, that is nothing but y2 minus y1. That is 5 minus -1 or 6. And what is delta x for the corresponding points? It will be x2 minus x1, or x2 is what? 1. So 1 minus -2, that is 3. Now what were we supposed to find? Rate of change of y with respect to x. So that is nothing but delta y by delta x. Delta y is how much? 6. Delta x is how much? 3. So that is 2. What does it mean? That for every change in x, for 1 unit of change in x, there will be 2 units of change in y. And that's what we see here. What is the change here? +2. What is the change here? +1. That's what we have seen here, right? For every +1 here, we have a +2 here. One minute.